This is for the melting point. You're going to need your mortar and pestle from your laboratory and your crystals. We don't need much for this, but we're going to crush some of the alum for two purposes. One is when we determine the percent sulfate, we need a gram of crushed alum so it will dissolve easily. So we're crushing it for that, but we can also pack our column. So take one or two of your crystals and with the mortar and pestle, crush that. And this is plenty here for you to mass out. It should be enough for you to mass out a gram of the alum that you'll then use in the determination of sulfate. But what I'm going to show you here is how to operate the melting point apparatus. These are capillary tubes. They're going to be right here. These are used capillary tubes, so that's where they'll go at the end. So you grab one of these. They are skinny little glass tubes they're like real skinny test tubes because they're closed at the bottom here and then they're open at the top. And we're going to pack our column. You just kind of drag this along the powder here in the mortar and pestle. And as you do that, some of it comes into the tube itself. You can make that out against the black background. And we want to pack it down to the bottom so that when it's in the device, that's where it is. And so you can just tap it like this and pack it down to the bottom. There's also up on the tray, right up here, it's off camera, but right up here on the tray for the dry erase board is a long glass. So right up here on the chalk tray, right up here is where you're going to find the glass tubing. Please return it there. And we can drop this through the top of the long glass tube. So right now I've got the base on a stool and I'm reaching to the top and dropping this into the tube. Let me do this also on the counter so you can see it bounce on the counter possibly. So there's the tube bouncing up and down. That, using a little physics there, the inertia of the powder gets slammed to the bottom. All right, so that's our packed tube. You're going to put that in the first well. We also want to do a commercial sample. So we're in this lab, we're analyzing how good our material is, our crystals are that we created, by trying several different properties. And so we're going to put a little bit of the commercial sample in here. Press this up. It's in a fine granular form, but to really pack it well, we'll pack this one also. Same technique, just kind of scrape along the walls there, and you'll get some in there. About a centimeter depth of the crystals is fine in there. And we will pack this. Alum is relatively harmless, so when we're done we'll get a wet washcloth and wipe all this up. So this is your sample, and this is the commercial. We can turn this on right here. There's a light bulb inside of this cylinder, and this cylinder is the heating element. Right now the voltage is at 0, so it's not heating up. Of course, this is our thermometer. And this is your sample, and this is the commercial sample. So put the commercial sample on the right. It only goes in there maybe about a centimeter and a half, maybe 2 centimeters possibly. It just goes down into a little chamber. There are 3 wells in there to fit 3 of these tubes. We're just going to use 2, and we'll just keep them on the left and the right. And then this melting element here, this heating element, block of aluminum that's going to be heated electrically, is going to heat up our samples. This is so that we can see what's going on looking through that eyepiece right there. So I suggest you turn this up to about 35, and that will slowly start to warm this up. And you look through that eyepiece right there at your samples. Don't crank this up, because if you crank it up it'll heat too fast. If it heats too fast, the thermometer will not be able to catch up. So as you're observing through the scope right here, through the eyepiece, you also should be monitoring the temperature, so that when it does start to turn slushy inside, as you're looking at your sample, note the temperature, Continue to look at it until it's completely a liquid, and then note the temperature again. That's the sample on the left, and then when we kind of move over, there's an empty well, and there's the sample on the right. And you just look for those to kind of turn slushy.